Good morning, my fellow mathematicians. How are you today? The reason I am calling you a mathematician is because a mathematician is someone who does math. And guess what? You're doing math. Even you, Mrs. O'Leary, are a mathematician. Today we're going to do, I'm going to just remind you of a couple things, then we're going to do notes, and then you're going to practice. So we're going to just start with the reminders. You don't need to take notes on this part. You can just kind of engage your mind and think and watch, but that's it. No other demands on you right now. Okay, so we did in class, we were looking at area of a square. And I'm going to remind you to find area of a square. So a square has four sides that are the same. So if this square is 6 centimeters, okay, to find the area, an area of a rectangle is length times width. That's rectangle. And in the case of a square, the length and the width are the same, so we sometimes say that the area is side times side, or area equals side to the second power, where S is side length. These are the same formulas, length times width. In a square, the length and the width are the same, so we sometimes use S. Okay, so in this case, the area of this square is going to be 6 times 6. And we saw that another way of writing that is the area is 6 to the second power, which is 36. Notice and remember that we call this the second power. We sometimes call it squared. Sometimes we call that 6 to the second power. And sometimes we call it 6 squared. And the reason we call the second power squared is because literally you are taking this 6 and you are literally making a square out of it. And you get 36. So we call second power squared because literally you are squaring it. So I'm going to erase this. You don't need notes on this, but some of you might like to be taking notes, so I'm warning you about the erasing. So to go the other way, if I had a square where the area is 49, whoops, it's really frustrating. Let's try that again. If I had, we're not going to do 49 because the 4 doesn't write very well. If I had a square where the area is 81 square centimeters, what is the side length? And to answer that, you need to know that what number times itself equals 81. I could also say what number squared equals 81. Okay, and we know that 9 times 9 is 81, otherwise known as 9 squared is 81. So the side length of this is 9 centimeters. I often forget units because I am more of a mathematician than a scientist. 9 centimeters. I'm just going to pause and collect my thoughts for a second here. So that is why problems like this are part of the reason why, and I'm going to erase this right now. They are part of the reason why you want to have your perfect squares memorized. Okay, so 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. 11 squared, 121. 12 squared, 144. 13 squared, 169. 14 squared, 196. See, those help you remember each other. 169, 196. 15 squared, 225. 16 squared, 256. We're going to 16. Okay, you really want to get these memorized. So one of the reasons that we have these memorized, and I am going to erase, is because if I say the area of this square is 225 square units, I guess we'll do centimeters still. What is the side length? The side length, if you know that 15 to the second power is 225, then you know that the side length is 15. If you don't know this, then that's going to be harder to come up with. Okay, so we are now going to do notes. Square root. This symbol is the square root symbol. Taking the square root of a number is the inverse operation of second power. And I'm going to explain what that means in a little bit, so you can just write that down and think about it. Okay, I'm going to erase this. So if you have a problem that says evaluate the square root of 49, okay, this means what number times itself is 49. Ran out of room there. Is 49. Another way to say that is what number squared is 49. Another way to say that is a square has an area of 49. What is the side length? These three statements are three different ways of saying the same thing. Okay, so square root of 49 is 7, because 7 squared equals 49. I'm going to erase this. We're going to try another one. We're going to do evaluate square root of 100. Okay, and I'm going to give you a little warning. You might be tempted to divide by 2. when you're doing square roots. Okay, it's not divide by 2. Dividing by 2, it says what number times 2 is 100. Okay, we're not dividing by 2, we're saying what number times itself is 100. Okay, so what number squared is 100? Or if a square has an area of 100, what is the side length? Okay, so the square root of 100 is 10, because 10 squared is 100. So we're undoing, so the square root undoes a square. Okay, one more thing I want to tell you, and this makes a nice long video for you guys today. I'm proud of you, keep it up. The last thing I want to tell you is square root and second power are inverses, inverse operations. So the thing that, whoa, I just moved my, okay, I can't figure out how to move that back, so we're just going to leave it like that. There's supposed to be an S on the end of that. Square root and second power are inverse operations. So you know inverse operations of addition and subtraction. So for example, if you have 5 plus 327.62 minus 327.62. Okay, these two things are inverse operations. Plus this number and minus this number, those are inverse operations. And to do this math, you don't actually have to do any math, because you know that plus 327.62 minus 327.62 cancel each other out, and the answer to this is just going to be 5. Okay, same with multiplication and division. You know that 5 times 327.62 divided by 327.62. You don't have to do this math out, because times this number and divide by this number are inverse operations. The answer to this is going to be 5. Okay, the same with squares and square roots. So if you have, I'm not going to use 5. I'm not going to use 5 here. I don't know how to erase, so there we go. If you have 327.62 and you're going to square it and you're going to take the square root of it, those are inverse operations. If you square it and take the square root of it, you are going to get that number. These two things, just like plus and minus cancel each other out, times and divide cancel each other out, square and square root cancel each other out, and the answer here is just 327.62. Okay, same, oh, I hope I'm not writing under my head over there. Same with if you did the square root of 327.62 squared. Those, the square root and square, cancel each other out. Boom, boom, because they are opposites, inverse operations. 327.62. So you're going to do a con, practicing some square roots, and you're going to want your perfect squares memorized. So spend some time memorizing those perfect squares.